Good day, and welcome to Smart Manufacturing in the Cloud from AWS. I'm Douglas Bellin, and I look after smart manufacturing within AWS. My role is to work with customers to help them understand where cloud makes sense for your manufacturing environment. Yes, IT is going to be important for this discussion, but this is also to try and bring together the other side of the business, operational technology, and how we can really bring this together and start to add value to your business as we move forward. Manufacturing and the industrial departments are really large across many of the heavy asset industries out there. This includes discrete and process manufacturing, agriculture, power, utilities, renewables, transportation and logistics, mining industry, and the energy or oil and gas industry. While there are major differences between these different industries, there's also quite a lot that is the same. It all comes down to getting something off of something in a remote location. It's coming off of assets which might have to run for 30, 40, and 50 years. Capabilities that have to be continuous improvement, looking at 1% and 2% improvement capabilities on an annual standpoint. But now looking at how we can start to accelerate that, make that 5 and 10, maybe even 20% type of improvements as we start to move forward. The trends that we're seeing across the industrial market are these 5 areas. 1, it's about the data. Data is an enabler to all of your businesses that you have moving forward. In fact, manufacturing and the industrial market is the largest producer of data of any industry out there. According to some estimates that we've read, it's about double the size of the next 2 industries together, which means there's a lot of data out there. We'll talk about the issues with that as we move forward. The move towards digital execution of the manufacturing environment, moving away from people doing manual inputs. People are analog. So how do we move to have them either being told what to do or take over that capability? Have the machinery fine-tune and understand what's happening and then start to make those changes. We all know about the headlines every day that's happening with supply chain. And what we need to do as an industry is start to restructure and change what our supply chain looks like, how it reacts, and how it becomes more resilient as we start to move forward. And then, of course, connected products. Now, this is taking the concepts that many of you have been using over the last few years from home, turning your lights on and off using some type of product that might not be connected directly to that lighting system, using voice and other capabilities to be able to have that new connected environment. This could be robots that start to move into hardware as a service, conveyance system that you pay for linear feet of movement per day. Or it could be adding the same type of thing that you have at home. One example that I talk with many customers about is, wouldn't it be great to be able to use voice? Being able to drive into work in your car and asking, what's my production plan today? Not running a report, but the report gets run in the back end and it comes up and tells you exactly what's going on. Before you go to lunch, being able to use your voice to ask, where are we at in my production plan right now? And maybe even better, what do I need to do if I'm behind plan? Well, that data is there. Those plans are there. Those capabilities are there. What we need to do is lighten those up, bring that together so you can have that capability moving forward. And of course, sustainability. Sustainability is moving away from that nice to have to the must have, must document, and is actually starting to add business value. So how do we bring all of that together into your business to help you start to change and understand where you need to go as well? Again, as I mentioned, though, there's unique challenges out there. Many challenges are what we're trying to solve right now. We're trying to look at how do we make it easier to get to that data. Many of your machines are 20, 30, 40 years old. The average machine age is about 22 years old right now. That means there's not a lot of connectivity on those. They may not have a Ethernet port, wireless, or other capabilities. Not only that, but there's hundreds of different protocols out there. Right now, there's over 350 different protocols and versions of software of all those protocols and that data that's streaming across in those areas. What we need to be able to do is normalize that data, which then goes into how do we build that data management structure. You have disparate machine data. Again, it's unstructured. You might have video capabilities, data capabilities, and more that start to come together. And of course, scale. We talk at the amount of scale that we're looking at per location. And again, the largest industry of data creation, but manufacturing is also the smallest consumer of that data. And that's because this data sometimes is behind 2 and 3 different firewalls. It's across disconnected machines. It might be across multiple different sites. And what we want to be able to do is get a single holistic view about what's going on. This data needs to be secure, as your environments have to be secure. Looking at what we can do to make sure that the data is the correct data, is secure, and isn't been messed with in any way. And of course, we look at real-time decision making. This decision has to happen at the edge within the factory. It has to happen as close to the creation as possible. Many times when you're creating items, depending on your industry, you might create something that's thousands of items per minute. Well, having that go to the cloud and coming back in 2 or 3 or 4 seconds is too late. We need that micro millisecond capability to understand what happened, how it happened, and how we can react to it. Of course, this has to do with latency and other capabilities that's beyond our control. But as we'll see, a lot of the technology that we've been creating and bringing to the market is going to help solve this. The key is data. When we look at Industry 4.0 or smart manufacturing or connected manufacturing or whatever buzzword you want to use, it all comes down to the data. Connecting the data, securing the data, moving that data into a stream to be able to have that data flow into something and become actionable insights. Data is actually not the right thing that we want to have. We want that data to be created into something that's telling us what the issue is and potentially how we can solve it. So what did AWS do? About 2.5 years ago at reinvent 2019, we came up with AWS for Industrial. And what this was a way for us to make it easier for you, our industrial customers, to innovate, automate, and scale industrial workloads through purpose-built services, solutions, and the widest ecosystem of partners. So what I'm going to do is take the next little bit to talk about each of these areas. What is innovation? What is automation? And what are these workloads that you're looking at? What are some of these purpose-built AWS services? What are some of these solutions, both from internally and with our partners? And of course, some case studies of what customers have done in this market. So why? Why AWS for this marketplace? Well, hopefully many of you work with our sister company, Amazon, or use them quite a bit. So you think about what happens within Amazon. When you place an order, it goes to a fulfillment center to find out the lowest cost routing to get that item to you as quick as possible. Once we're able to do that, then it goes into an incredible amount of operations. And this operations is a lot of the same type of things that you use. Typical fulfillment center, if we're looking at an automated fulfillment center, typically has 20 some miles of conveyance systems. It has a lot of other information out there. Robotic systems that are working in harmony with people to ensure that that item is picked, packed, and delivered to you on time. Well, we take that data and we look at what's going on within our operations and look at each of these industrial sites to be able to deliver that information centrally to us so we can understand what's going on at each location. Because of that, we have purpose-built services to optimize these operations within our factory operations. And again, factories and fulfillment centers, many people don't think of as the same, but they are very, very similar. What we've been able to do is bring multiple different services to the market to be able to deliver both internally at Amazon and within our customers to bring these services and solutions to bear. Also, when we look at our incredibly large partner offerings, we have an incredible amount of worldwide industry leaders that bring together a huge amount of solutions. And these solutions are from those industry workloads and those business use cases that you're looking to drive. We've looked at this and we've been told this is larger than almost any other partner out there. And it's a way for us to be able to bring those into a unified platform to be able to deliver from a business case aspect. What we ultimately want to do is help you deliver business outcomes faster. This is not about technology. Well, it is ultimately, but the reality is the technology is there. The technology has been proven. The technology is something that we're able to deliver and keep innovating on. But to make it easier for you, we've got 3 ways to be able to have these outcomes come to you faster. One is you can go off and build those. You can take the AWS services and solutions, over 280 different services that we have available to you on the AWS cloud, and build what you need to do. Sometimes we've already done some of that building to bring you higher level services. And these services could be higher level capabilities, maybe AI and ML, maybe reporting capabilities or other things to be able to give you better insights. At the same time, we can actually go into our partners. And our partners, be it an ISV, a global systems integrator, or others, are able to bring these solutions to market. Some of these solutions are available for you today on the AWS market space, where you can go in and click and download an offering very quick and easy. No building. What you need to do is bring the data, they bring the application, they bring the business outcome to you, and you're ready to go. But there's also what we're seeing in the middle, both a build and buy or build and deploy strategy, where we engage both our partners and our professional services arms to be able to bring you exactly what you need. Many times that software pack may not be perfect for you, but what we want to be able to do is customize that and bring that to bear so you can actually start to have that exactly for your business. So we can take both our partners and our professional services and that software and all those services together. And it's the power of and, bringing all of that to bear to be able to even customize more for you. To do this, and looking at Industry 4.0 or smart factory capabilities, this needs to be a hybrid architecture. Again, part of this has to do with that latency issue. So we need to make sure that that workload is available for you as quick as possible. Also, many of your environments are not in the best connectivity locations. They're probably not in downtown locations. They might be off in far remote locations, somewhere in remote locations. Now, what we need to be able to do is make sure that even if the network goes down, even if we have that capacity go down, we need to make sure that your operations still work forward. So looking at all those capabilities from Industry 4.0, Internet of Things, cybersecurity, additive, augmented reality, big data, simulation, autonomous robots, vertical and horizontal integration, and of course, cloud coming together. What we're able to do is use cloud for harnessing many of those cloud and virtually unlimited compute and virtually unlimited storage capabilities to bring you new processes and new capabilities from a technology standpoint. This could be AI and ML, bringing that huge data set and finding that little nugget of information. Again, the other part with these big data sets is there's no network that can move those across as quick as you might need them to do. So we probably need to do some edge processing or pre-processing, understand what's in that data to then move the relevant data sets across so we can start to change our business moving forward. And of course, this has to lower costs. Looking at those sets of data, sets of employees that you have, the skill sets that they have right now, and how we can help them change their business as they move forward, change what they're able to do and be able to drive that as well. Well, to do this, we've been able to change a lot of our different proposals and presentations to you. The product portfolio is changing incredibly fast to be able to support that edge capability. So if we start on the far left over here, where we see regions or our availability zones, this is typically what cloud was first thought of. This is our data centers, our availability zones, our local zones, which are typically, when we build an availability zone, it's 3 different buildings across 3 different floodplains, across 3 different power platforms, to be able to bring you a virtually one point of presence. Now, you as a customer see this as one location, but behind the scenes, there's 3 buildings that are occurring with 3 different data centers with security, development, deployment, and management capabilities for you to be able to bring that together. Now, from here, as we start to move over further to the right, that's when we're getting closer and closer to where that data is being created. Things like AWS Wavelength, which we're integrating our capacity and capabilities into 5G environments, putting it right at that 5G edge to be able to allow you to compute right there. Outpost is the same hardware that we have in our availability zones, which are now available for your locations, your facilities, So we really can get in your sites. Now, what does that allow you to do? That allows you to design once, manage it once, program it once, and deploy at any location without the fear of that network going down. As we move further and further to the right, we see Snowball and AWS Snow Cone, which is a way for us to bring storage and light compute capacity down even further. So the further to the right, again, as we move, we're starting to move more and more to the edge. That first edge standpoint is your facility, the edge of your location. As we move down from AWS Snowball into AWS Snow Cone, that's when we start getting into maybe a line level or a machine level edge capacity. Snow Cone is a really small disk space that has some compute on it and storage to allow you to understand what data needs to be moved. Understand, is that data good or bad data, and what we need to do with it. Snowball, think of that as a higher level storage capacity with a little bit higher level compute. Now, what we can do with that is look at a line or look at smaller locations before we even move that off your network into a public mobile infrastructure. Move it into the cloud aspect as you start to move forward. If we keep moving all the way to the far right hand, we see IoT Edge and Amazon Free RTOS and IoT Greengrass, which are actually applications that can run as close to that data that's being created as possible. AWS IoT Greengrass is really a way for you to run applications. This could be containers. This could be Lambda functions and other capacity to be able to run as close to that machine as possible. Moving into SiteWise, which is a way for take that data, and now you can start to take that data and model it right at the edge. That modeling is, what does the data look like? What does that data look like for the machine? You can either create that on the cloud, in Outpost, and then deploy that within the edge environment. And again, that IoT SiteWise Edge is now where that is running within the customer's location. Now, there's a lot of other capacities and capabilities in here, but what this is showing is that that cloud is becoming more closer to the edge, and the edge is becoming integrated and integral to that cloud environment. And all of this has to work in harmony. Now, to make this work, we kind of have a solution framework. And the solution framework goes from collect to store to analyze and ultimately to act. Each of these layers can be independent, can be built or acquired, or installed depending on what your location is. We have multiple ways to collect that data. We have multiple ways to store that data and analyze and act upon that data. And let's look a little bit deeper into what this framework does. So if I tear that framework down a little bit and start to look at the different parts, way down at the bottom, you have operational data, historians, SCADA systems, and MES systems that are out there. These are your ERPs, your other systems, or your statements of record that probably don't need to be replaced. You may upgrade these periodically, but many times those are programs that are put in place and built and never touched again. That's where the wealth of data lives. That's where we need to be able to understand how we're going to move that data off of there and start to, at the edge, understand what the data is telling us. Again, I didn't say replace those systems. Now, you may modernize those systems. You might start putting them away from old mainframes or other capabilities and start to modernize them a little bit for newer and greater capacities. Well, that data is still going to be at that edge location. What we want to be able to do then is move that data into that edge where we can do both connected and disconnected modes to understand what that data is telling us. We can do some local decisions on that. Is that data actually telling us more information as we start to move forward? We can start to securitize that data and then start to move it up into the industrial IoT. That IoT is a way for us to have that connectivity, have that event processing to start doing that first level of where does this data need to go? Or who do I need to tell this data? Who do I need to tell about this data as we start to move forward? This starts to get ingested into an AWS environment and then normalized so we can start to understand the different protocols, the different software packs, and not have to worry about the data before we land it into a platform. Now, once it moves from that industrial IoT, we typically want to get it into a data lake. That data lake is going to allow us to understand how that data is being stored. Once it's there, we can start doing a lot more with it. That data is now available for us to build asset models or bring our partners asset models. And these partners could be the people who made that machinery for us or the software for us to help us make that data actually be usable. That could be contextualization. That could be dashboards and alerts. That could be 3D capabilities. That could be AI and ML capabilities to be able to bring that together as we start to move forward. That could be VR for visualization. But ultimately, once that asset model is there, we don't have to worry about that data because it's been stored, it's been normalized, and it's been moved into a central location. That data on that data lake can now be used for multiple things. We might build an asset model. We might want it to go into time series data. We may, for a different question, want it to go into relational databases. But because we've had the single source of truth now in that data lake, it doesn't matter where that data starts to go. You can start building citizens who want to go after that data. Think of your employees who have now free reign in the right data that they're able to see in a secure format, of course, that they're able to see, that they're allowed to see, that they can then start to ask new questions on. These new questions could be anomaly detection, could be dashboards, could be alerts. Again, this could be things that have been built already, both from AWS and with partners. And the ultimate goal here is that once we've built that stack up to that green data platform location, everything from that standpoint forward becomes easier to install, easier to use, and easier to implement as we move forward. Now, I've mentioned a few times some of the AWS services for industrial customers that we've come out and built. So when we launched AWS for Industrial, we came up with the top 6 programs on here. These 6 programs have been iterated. They've been gone through a few iterations, some new capabilities added to them, and some new feature sets over the past 2 years. These are AWS IoT Sitewise, which I've mentioned before. It's a way for us to really look at that data, collect it, store it, organize it, and then build monitoring capabilities from that industrial equipment. You can build a model once and deploy it multiple times as you start to move forward. Maybe you have multiple machines that are the same in different locations. They might have different data sets on them because of the age of the equipment. They might have different capabilities built into them, but what we're able to do is build that model once and deploy without the users having to redo it every time. Panorama Appliance and Panorama Device SDK have to do with video capabilities. Panorama Appliance is literally a hardware as a service appliance for you, which includes everything that you need to do to add AI and ML to your on-site video cameras. As long as these are IP enabled, we can now put this hardware appliance in the middle, which can do multiple video streams, and build on top of that video AI and ML capabilities. This could be able to very quickly bring that to the marketplace and actually going to our marketplace and downloading capacity and capabilities into the appliance for you. Panorama Device SDK is for the new cameras and devices that are out there, which now have things like NVIDIA chips built onto them, which actually allow you to run AI and ML on that chip. And that chip could be on the camera. Once that happens, now you're truly running at the edge. And again, even going from a camera over an IP stream back to a Panorama appliance, there's some latency. There's some time dependency in there. So if we don't even have to move across that network and can able to do that AI and ML at that camera, we're able to help our customers move even faster. If we do look out for equipment, that's a way for us to look at the data sets that you have, the sensors on those machines, and detect abnormal machine behavior. It sounds magical, and it almost is. But what it's able to do is take a data set from that machinery, download that, and output as simple as a CSV file. That CSV file can be put into Lookout for Equipment, which looks at that data, and that data just has to have a time stream data stamp on it, just has to have a sensor value, and hopefully a time frame of a few weeks or months of what that data is looking for. Let's say that machine has 5 data sets on it, 5 different sensors. What we're able to do is the Lookout for Equipment looks at each one of those sensors and says, this is the type of data that we're seeing, and brings an AI pack to that data set. It then runs across that data stream and looks to find out where the good behavior is and the bad behavior is. And it shows you that behavior and shows you any abnormalities that are occurring within that. Then what it's able to do is take that and combine all the different sensor combinations. So it can combine sensor 1 and sensor 2, 1 and 3, 1, 2, and 3, 1, 2, and 4. Keep going from all the permutations. And it does it automatically behind the scenes. It does the same thing. It brings together an AI and ML engine for each of those data sets and the combinations of the correlation of all that data set, and shows you the good and the bad behavior. Now, all this is doing is detecting and highlighting where that abnormal behavior is. But the next step is then to tie together things like your maintenance logs. If you're using a maintenance tool and somebody's updating when those files or when those machinery is being fixed, now what you're able to do is put that in, and that should also have a timestamp on it. And now what you're able to do is correlate that timestamp of what you fixed to the issues that were occurring before that. Now what you're starting to do is build out a predictive maintenance model. That then allows you to modify, change, and keep looking at this from a day in and day out basis or a weekly basis to look to understand where abnormal behavior is actually occurring, which might be a precursor to failure or issues before they start to occur. Lookout for Vision is a way for us to bring computer vision capabilities to you, our customers out there. What this does, it spots defects and anomalies in the manufacturing environment. Typically, easiest way to think about it is surface detection. What does a perfect surface look like? And then what do abnormalities in that surface look like, and train it very quickly. Amazon Lookout for Vision can actually be trained in about 40 frames of video, combination of good and bad, to help you understand where that capability starts to occur. What this is going to allow you to do is actually start to put more cameras in place across your line to quickly understand good and bad camera behavior, or in other words, good and bad surfaces. If I can understand where those good and bad surfaces were occurring or good and bad anomalies were occurring, then what we're able to do is find out what the issue is. Amazon Monitron is an end-to-end system for monitoring of this equipment, which sometimes doesn't have sensors on it, or those sensors are analog and hard to get to. What it also does, it helps to enable predictive maintenance as you move forward. It's actually an incredibly simple process to build out and deploy. What it is, you literally go on Amazon.com, you search for Monitron, and what will occur is there will be a single package that will appear within Amazon for Amazon Monitron. You can order this for a pretty decent price of under $800, and it comes with 5 sensors and 1 gateway. To install it, you open the box, pretty simple from there. You take out a sensor, you NFC it, you NFC the gateway, and now those two are talking to each other over secure Bluetooth. You install by gluing that device onto the rotating equipment that you're looking to monitor, and within minutes, the data will start to stream to AWS. You'll actually open up an application on your phone, which then was tied to that gateway, which is tied to each sensor, and you see each sensor's behavior. On that sensor is temperature and vibration, and you can start to build an actual model of that individual equipment. These can be deployed quickly and fast to be able to allow you to be able to get insights into equipment that you might not have been able to get insights into. AWS IoT RoboRunner is a way for us to build together a single platform to help robots work together seamlessly. Now, nothing wrong with the robotic companies that are out there, but each one has their own programming platform. Each one has their own capability, which is great for what it does. But if you start to build a robotic environment of multiple different vendors out there, maybe using mobility robots to move material around and stationary robots to pick up that items and put them into different locations. Well, 2 different vendors, 2 different programming, and it's almost impossible, not 100% impossible, but almost impossible to get a single view of all of that environment. AWS IoT RoboRunner is actually the way to allow you to get that single pane of robotic glass. In other words, how do I go from a mobility robot to a stationary robot to maybe another mobile robot and so on from that standpoint? RoboRunner, as long as we're running on ROS, which is Robotic Operating System, will allow you to do that. AWS IoT Twin Maker is a way for us to help create digital twins of real-world systems to optimize operations. What this does, it works with many of our partners in the digital twin creation business who have all those different unique areas. The problem is, just like RoboRunner, there's lots of different parts that make up digital twins, a digital twin environment. And what we want to be able to do is allow you to use that single IoT twin maker to be able to build across all those environments. Now, what you're able to do is tag and build and see what's going on across that environment in a single area. At the same time, besides those high-level services, which are tying together many times in multiple services, we've actually brought some solutions to bear for the market. These are available for you to go and download for free across aws.amazon.com solutions. These are Amazon Virtual Andon, Connected Factory, Smart Product, Machine to Cloud Connectivity, Predictive Maintenance, IoT Device Simulator, Scale-Out Computing, and many more that are available for you. These are built and deployed by many of our customers globally to be able to help them take that first step into their cloud journey. We also have many programs for those of you who are still builders out there. These could be solution architects, people on our team who will sit with you and are dedicated to your account and your industry. You can work with them to brainstorm on ideas and use cases and get solution implementation support. In other words, you don't have to do this on your own. These solution architects are there to help you take that first step in the journey, but also understand while you move down that journey, the right path to take. We also have our AWS professional services team. We have discovery capabilities, advisory capabilities, and implementation services along with our partners. Many times they run training workshops and hackathons for the builders within your organization to help them get improved to that next level. We also have ML and IoT Solutions Lab, which is a way for us to bring our machine learning experts, our AI and IoT experts to you to be able to help build proof of concepts or custom solutions for your use cases. Now, many times we might have something that we've done and we can start kickstarting that, but then there's customization that has to be done. And we also do have our AWS Partner Network. These are AWS validated partners to help you with your POCs, your integration with your current systems to move from proof of concept into production. These include many times our industrial domain specific expertise, not just from an IT standpoint, but from actually what's going on in your operations as well. So when we look across this workloads, where are customers actually seeing cloud add value? Within engineering and design, what we're seeing is customers are being able to quicker and easier actually design new product portfolios, lower their infrastructure costs, moving away from on-site, non-premise, high-performance compute, and moving into a secure worldwide collaboration capability that their users can quickly get into and scale when they're doing design capabilities. When we look at production and asset optimization, customers want to lower cost, increase asset availability, increase product quality, and increase their human resource productivity. Across the board, this is really looking at what's going on in the factory facility. Within sustainability, customers are looking at how do I meet those top-line sustainability targets that my executives are looking for and the board wants us to be able to do. But at the same time, this is going to help us go into process optimization, reducing wages, in other words, water, air, gas, electricity, and steam, which are all those components that make up that sustainability report. I mentioned supply chain earlier and the confusion and the capabilities that we're seeing out there. The problem is right now, supply chain is huge. You can only control so much of it. And every day we seem to be getting more and more supply chain issues. First step for many people in a supply chain is understanding what you can control. What is your forecast? What is your factory accuracy that you can start to improve? Once you can do that, then we can start to go across that supply chain and working with others to start to react to where those issues are occurring to make it better and easier for you. This will help with resiliency and reduction in inventory costs to be able to react to where those changes are occurring. And of course, smart products and services. This is to make that user experience better. Who are your users? Your first level users are your factory users and how they get that product out the door. But then ultimately, if you're creating some of that product, your users are those people who are buying that equipment from you. This will help create new revenue streams where you're getting into hardware or operations as a service capabilities. And as a user, you're going to be able to improve product and service quality at the same time. So let's look at engineering and design. So engineering and design, both, again, there's ways to build and deploy and engage these capabilities. If we look at that build capability, we have an AWS solution called scale out computing. What it allows you to do is look at building your high performance compute cluster on the cloud, but also build it in a way that can scale. In other words, if you hit the roof, the theoretical roof of your own high performance compute cluster, you're done growing and scaling. But with scale out computing, when you hit that perceived threshold or that ceiling of the amount of users that can be on that environment, it will automatically build that out. It will build and deploy a new instance for that new user as they come on board. We have multiple different partners in here with Autodesk and Siemens and Synopsys and TwistThink who actually have these solutions to be able to deploy for you. Some of these are the revamping of their hard software behind the scenes to allow you this to be software as a service capabilities. And in the middle are ways that we can actually engage with these different use cases. So this could be simulation, computer-aided design, PLM, CAE, semiconductor EDA, and product digital twins. That's just cutting the surface. Of course, there's more use cases, but let's look at one of our customers that have done this. If we look at LG Electronics, what they're able to use was use nice DCV to accelerate their product design. The problem was that they had a problem with users in remote access. And I'm sure over the past couple of years, especially when COVID first started, many of your users who were in the engineering design space went through the same thing. They moved away from their desks where they had a great network into their home environment, where now they were coming in from things like VPN or other capabilities, and the network wasn't big enough to allow this capacity to move forward. So together with ISBC, LG Electronics use our software, Nice DCV, their CAE software, and a customized Nice engine frame to simplify the process of building up new capacity for their applications. What this allowed them to do was build flexibility for their engineers to be able to work remotely. We didn't have to worry about the network because everything was happening now behind the scenes. What this allowed was that remote engineer could be no longer on-premise, but they could still access remotely the on-premise software. From a cost-saving standpoint, it allowed GPU sharing, and it actually supports about 10 to 15 users per GPU. And each workstation can now scale to over 2,000 workstations as they move forward. And improved collaboration between the engineers because they didn't have to wait. They didn't have to wait for compute time. They didn't have to wait for access to this capability. These engineers could actually start to build and look at it in real time. Woo-Sung Kim, the HPC professional engineer for LG Electronics, said Nice DCV had the best performance for speeding up graphic resolution and low latency, and it was simple to manage for high performance computing. Next, let's look at Smart Factory. Smart Factory is a way to start looking at, again, the build, the deploy, and the engage capabilities. We look at production and asset optimization. We look to the different use cases that are out there. We have multiple solutions out here of machine-to-cloud connectivity, virtual and-on, SAP quick starts, IBM Maximo quick starts, predictive maintenance using machine learning and look out for equipment capabilities, document understanding solutions, streaming data solutions for Amazon Kinesis, and AWS computer vision solutions, such as Lookout for Vision, to be able to allow you to look at that quality capabilities. This has a wealth of partners out there and partner solutions, including Siemens and Deloitte and Hitachi, Proteon-Tex, Clickatek, Basler, Wipro, Tensor IoT, Seek, and BigMate, which are pre-built offerings and solutions. Some of these could be a full end-to-end capability from data acquisition to data storage, to reports and analytics, to actionable insights to allow that capability for you. What this helps solve are these different use cases of machine connectivity. In other words, how do I get the data off that machine that might be hard to access? How do I improve OEE? How do I look at that digital twin and understand what I might be able to do to react to it if it's starting to stray from the perfect type of creation that we're making? Could have defect or object detection, as we talked about with Lookout for Vision, or other type of computer vision solutions. Predictive quality, production floor digitization, modernizing MES and moving away from that monolithic historical system that people had into more of a micro application type of MES. And health and PPE detection, which was a big one the last couple of years and will not be going away. How do we ensure that people are safe? How do we ensure that people aren't sick as they're coming into work? Using technology to be able to help allow that to happen for us. One of our customers is Invista, and Invista makes nylon, and one of their products is Nylon 66, and it is actually built into products that many of you use day in and day out of Stainmaster, Cordura, Antron, and other products from that standpoint. Ultimately, Invista is a chemical company that brings together that chemical process and that chemical technology for you. Their challenge was when they look at the production line, they had tons of different data, but it was locked down in each location. What would happen is people would have to go to multiple different data sources, multiple different data sets, look at that data, first extract that data, then normalize that data, then try and figure out what that data is telling them, then write a report on it, which took a long time. So what they did was they used AWS Lake Formation to implement a company-wide data lake based on Amazon S3 and AWS Glue. So what that solved was those first two lower levels of connect and store. They also use Snowball devices to migrate large data volumes from plants into the data lake. As I mentioned before, the largest production of data is manufacturing. They were swimming in data and actually drowning in that data, and they didn't have a way to move that data quickly across. AWS Snowball devices actually can move that data physically for you by being able to copy the data and then bring it to an AWS environment, which then copies it onto the data lake for the customer. Some of the benefits that Invista saw was that there was an incredibly large contribution where they had said that they wanted to create $300 million of value from the data that they had out there. The big thing that they were able to see was a reduction in unscheduled plant downtime, which I think everybody has and everybody wants to reduce. And of course, a little over 2 million in annual data storage savings. Once they move that data over those AWS snowballs into the AWS data lake, what they're able to do is delete that data locally. They knew they had it up on the AWS environment, so they're able to eliminate that on-premise data storage that was sitting there of historic data sets. Elizabeth Gonzalez, the analytics leader for Koch Industries, who owns Invista, says, by using AWS to pull ordering patterns and other data from our SAP ERP systems, we have a closed loop, fully automated stocking process for high-moving spare parts that has shown significant return on investment. If we look at sustainability, and again, looking at that build environment, we have our actual solution called the product carbon footprint. So how much carbon footprint was built to use to build that product. And of course, there's emissions monitoring and surveillance capabilities that you can use to build by using some of our predefined templates. At the same time, we have multiple different partners out there, such as Siemens and Seek and Hitachi and Pressac, to be able to actually have off-the-shelf products to be able to help you from a sustainability standpoint. And we have those use cases. Those use cases are, how do we help with smart buildings? What has AWS and Amazon done with our smart buildings? And how do we help deploy by using some of these templates into your environment? If we look at a customer, CCI, which is Coca-Cola Içecek, it's one of the key bottlers of the Coca-Cola systems based in Istanbul, Turkey. What they do is produce and distribute beverages across Turkey, Pakistan, Central Asia, and the Middle East, serving more than 400 million customers. What they relied on was an analog process for asset measuring and monitoring. They didn't have a single dashboard of seeing what was out there. What they wanted to be able to do was be able to do better maintenance tracking, better process tracking. But right now, historically, it was done by hand. So they would go out, they would write that down on paper, they would bring it back into an Excel spreadsheet or other things and be able to look at how that information was being used. They didn't have a way to build that once across the different production lines, or how that was being used across the production line as well. So what they did was they decided to digitize its shop floor and manufacturing processes. And this helped them allow them to create a complete digital twin solution. The ultimate goal was for them to be able to deploy this at all 26 bottling plants. In 2 months, CCI, with the help of AWS Professional Services, built a robust digital advanced analytics solution for its production line, including sanitation processes, which using the AWS IoT Sitewise and AWS IoT Greengrass for data collection. What this allowed them to do was process efficiency, looking at clean in place, looking at other things from a water and power usage to be able to reduce that. The savings that they saw was 20% savings in energy and 9% savings in water annually. This optimized their clean in place process, time, and cost performance overall. The asset optimization digital technology leader at Coca-Cola Içecek said between 2021 and 2023, we expect to regain 200 production days by implementing the digital twin of their clean in place process. If you look at supply chain management, people come to us all the time around what does Amazon do from a supply chain standpoint? We're bringing together more and more best practices from what Amazon is doing for you, our customers, to be able to follow. This could improve forecast accuracy with AI and ML, or even the Amazon forecast product portfolio. Looking at our managed blockchain and be able to ensure that that data is the right data, hasn't been modified, and we can actually track who modified what information as we start to go forward. Partners out there include, but not limited to, Deloitte, Slalom, and Tensor IoT. They actually have many of those different software packs and packages to allow you to understand what's going on across your supply chain. Now, within the supply chain, there's hundreds of different use cases, but we also have pre-built use cases around automated material handling with many different partners out there that bring robotics, but also scheduling capacity. We have our demand planning infrastructure to allow you to understand what's going on and how you can react to it before it becomes a big issue. We have our warehouse management to be able to understand within your warehouse where the products are, what's happening with those products, what's the dwell time, what's the throughput. Supply chain tracking to be able to understand what's happening across your supply chain and get better visibility to understand where some of those choke points might be occurring. Improve your on-time in full compliance to understand and ensure that your products are moving forward and your customers are getting what they ordered. Looking at inventory optimization and actually staging inventory potentially before customers order it. And of course, finally, dynamic scheduling. These are multiple different use cases that we either have areas to build or partners to be able to deploy as you start to move forward. An example of this is Carrier. And you probably know Carrier from the heating, ventilation, air conditioning, and refrigeration systems. They have 51 factories, 39 different design centers worldwide, and 53,000 employees serving customers in over 180 countries. Their challenge had to do with cold chain. And if you think about the different providers of a cold chain, you've got warehouses, you've got trucks, you've got transportation systems. What was difficult was getting that holistic view across that full supply chain. Every time you have a different handoff, you might have to have a different change of the different technology in there. Also, when you start thinking about different things that are moving across that supply chain, you might have temperature fluctuation. And the fluctuation might have spoilage. You might have equipment malfunctions, might have human error. You might have external events which are beyond your control, but you need to understand where those issues were occurring. So built on top of AWS IoT services, Carrier Link's platform was a way for us to help across that full end-to-end standpoint, collect, integrate, organize, and analyze data from their large installed database of refrigeration equipment and monitoring systems that were already out there. This provided a comprehensive view of the cargo, the temperature, the location, and all external events that were happening out there. And they've seen incredible capabilities. They've seen better visibility, resiliency, and agility and efficiency across that full cold chain. It helped them reduce energy usage. It also allowed them to reduce costs, delays, cargo loss, and spoilage while in transit. David Appel, the president of Carrier Refrigeration, states, through this collaboration with AWS, we're developing a uniquely powerful ecosystem to give our customers greater flexibility, visibility, and intelligence across the cold chain. Looking at smart products and services, again, this is a way for us that we're working with many times those builders of machinery that are going into those facilities. This could be robotics, this could be conveyance systems, as I mentioned, or any device that goes into a facility. What we've done is built basically a repeatable pattern for smart product solutions that you don't have to create it every time. You can follow this pattern and start to integrate that into there. It includes a device simulator to be able to understand the type of data that you're going to be creating. We've come up with a machine to cloud connectivity to make it easier to get that data from that remote location on that remote machine into an AWS environment. And so you can react to that, what's going on from that data standpoint is the AWS Connected Mobility Solution, which allows you to see that data from your handheld, from remote locations, from anything that you might want, from tablets to desktops and beyond, to be able to ensure that the data is accessible for you, either the operator or the person running that machine remotely. We also do have a way to be able to deploy this with our partners, with Hitachi, Luxoft, OSIsoft, and PTC to make it easier to integrate those capacities and capabilities as you move forward. Some of the use cases that we're seeing is smart product, business to consumer capabilities, but also smart industrial machinery, B2B, technician scheduling, warranty and recall execution, and maintenance business transformation. Looking at where your business sometimes spends that money, but also how we can start to have that better insights of your business with the people who are providing that information and those machinery to you in real time. An example is a company out of Italy called Arneg. They're the leading manufacturer of commercial refrigerators. They have 20 production companies and 17 international offices to drive a global distribution network in over 100 countries. What they wanted to build was a fault-tolerant, scalable solution for its existing services with new services as its offerings were expanded. Also, what they wanted to do, and this was an SLA to their customers, was create a quicker time to resolution. So when the system does have a problem, how are they aware of it? And then how can they react to it before it becomes an issue? The solution was to collect over 11 million IoT records daily, such as temperature, energy consumption, and failures through sensors in the freezers and refrigerators that send this data to the cloud. Now, once it's on the cloud, it's standardized for processing to be able to deploy and manage that capability. They use Amazon Forecast and Amazon SageMaker to find those issues, notify the right people before an event is likely to occur, which then gives that service team time to monitor the equipment and notify the maintenance personnel in advance. What they did was they built a predictive maintenance model using ML to reduce the downtime in SageMaker. These models from all those different records were in hours, not days. To be able to predict with an 80% accuracy when maintenance was needed before it was a failure as they start to move forward. Claudio Canepa, the Chief Information Officer for Arneg, says, the AWS architecture provided to be a great and powerful innovation enabler. Overall, how did this start? Well, we started this with simplifying the digital transformation, ensuring that the data is running your business. As we mentioned many times, the industrial environment is drowning in data. You're the largest producers of that data, the smallest consumers of that data. So how do we help you transform your business by using our partners, our solutions, and our capacity to help you understand what that data is trying to tell you? With that, thank you very much.